they're happy to manufacture. Of course, they prefer to be here at a higher price, and they will provide more, of course. One other item that I would like to discuss, and then we'll choose problems, is cost, revenue. I need this. It's not in this section, but I need it for later. Cost, revenue, and profit. So I would like to go through this quickly, and we will come back to it several times this semester. Okay, so what is the cost? The cost function has two components: fixed, I don't know, rent, electricity, etc., plus variable. Variable depends on how many units we manufacture. It's raw material, it's labor, etc. The cost function is normally written like C of x, total cost. Let me write total better. Total cost is fixed plus variable. Fixed cost plus variable cost. So normally this is a number, so it's a fixed cost plus a variable cost function of x. This does not depend on x. X is the number of units. Units produced. Does not depend on that. Fixed. Does not depend on x. Variable, it depends on how many units I manufacture. Okay. Revenue. Revenue is R of x, which is normally the price times x, price per unit. Finally, the profit is always the revenue minus the total cost. And what is called the break-even point is the point where the profit is 0 or revenue equals cost. C of x, I should have written. Okay, so please remember the break-even point is when the profit is 0 or when these two are equal. Same thing. Revenue is the price per unit times number of units produced. Total cost, fixed cost plus variable. That's all I had to say to refresh your memory on, and now I'm going to share my screen. And we'll go to the book. Where is my book? I think it's here. And I want to go to here it is. Sorry guys, you're always in the way. Nope, it's not there yet. Just kidding, of course. Okay, here it is. So graph each pair of equations on one set of axes. I don't think we need to go through that, but if you want to choose, please do. These are more sophisticated problems like 33 and 34 and 35 and 36. They will come up in this course quite a lot. We are not equipped at this point to graph any of these unless they are simplifiable, which they are. So we can. I just see that. But more complicated will come up. So this is possible. They're not rational functions. You will see why. We can determine some domains of functions if you want to choose from any of these.
Could we do one of the first problems?
Allow me 1 second to mute the view again. Okay, back. Yes, where am I?
Could we do number 5?
Number 5. Number 5 it is. Okay, 5, 5, 5. Okay, I see it. So y equals negative 3x squared, and they want a negative 3x squared plus 2. Okay. So when we graph these particular functions, we should start, because these are simple basic functions, right? These are transformations, simple transformations on x squared. So you may remember or you may not remember what happens when we multiply x squared by negative 3. So the graph of x squared, again, I'm skipping steps because I want to use transformations. So this is x squared. This is this piece, the base function. What happens when we multiply by 3, first of all? Let's multiply by 3. What happens? Anyone remembers what happens when we multiply by 3?
The graph will become more narrow.
Yes, we are stretching the graph. That's it. So this is 3x squared. But now what happens when I multiply by negative 1?
Does the graph flip?
Very good. It flips indeed. So this is the graph of negative 3x squared. And now negative 3x squared plus 2, where will the graph go?
Moves up 2 spaces.
Very good. Excellent. So here's the graph. So this is, I'm going to do this so you can see that this is the last one. So this graph is negative 3x squared plus 2.
Thank you.
Sure. So these are the transformations. We use transformations to quickly graph the graph. Now, do I know where the intercepts are? No, I don't. I have to calculate. I do know this one, though. Can anyone give us this point for this function?
0, 2.
2. Excellent. Well done. Good. So let me share again. Other graphs you would like to see? Again, they're all transformations. We can look at these that I just mentioned.
Yeah, can we do 34?
Yes. So let's do 34. In 34, we have f of x squared plus 5x plus 6 divided by x plus 3. Perfect. I'm going to stop sharing. Good pick. Okay. So what type of function is this? It's a ratio of 2 polynomials, so it has to be
Rational.
very good. Now, first step has to be domain. Now I cannot skip any steps. This is not the basic situation. Okay, so what is the domain of this function?
Is it negative infinity to 3?
But 3 plus 3 is not 0.
Negative
Yes, 3. Awesome. Yes, indeed. Union negative 3 to infinity. Awesome. Good. In number 2, I will show that table. Remember how we put the domain? We have to put the domain in the table. So I have negative infinity, negative 3. 0 has to be in the table always, and infinity. And this is what I need to do. Please pay attention to this. This is very important. The function has no value at negative 3. There is no function value at negative 3. Good. Next step, I go back to the function before I complete the table. And tell me, what would you do as the next step? Here's
Back
my...
to the numerator.
Thank you so much. Who was that?
Nick.
Thank you. Can anyone help us factor this? Not Nick.
It would be x plus 3 and x plus 2.
Awesome. Great job. Who was that? Megan. Thank you.
Megan.
Okay. What do I do next? Look carefully at the function.
Could you cancel out both
I
x
will
plus
simplify x plus 3 with x plus 3. Remember, I cannot do this before I state this restriction. If I simplify before I state the restriction, that will be wrong. So that's why the first step is always domain, not simplifying the function. Simplifying the function is in the process, but not the first step, ever. So this is x plus 2. So that's what I said. It will end up not being a rational function. Okay, moving on. I need ordered pairs. Okay, fine. Let's say -4 on this side. Let's say -2, and let's say 1. So please plug in -4 and tell me the answer.
-2.
Excellent. Please plug in -3 and tell me the answer. Right here inside the parenthesis.
-1.
Excellent. On the other side, and you can say, just copy -1 is the same function. Yes, I will copy -1. With -2, what do we get?
0.
Excellent. With 0, what do we get?
2.
Good. And with 1, we get 3. More than enough. So now in step 3, we graph. So let's graph the function and then identify the range. Here, I could not get away with a shortcut. I had to show all steps. Okay, so first order pair is -4, -2. Here it is. Next one is -3, -1, obviously the same on both. So -3, -1, how do I plot this point?
Open circle.
Thank you very much.
Okay.
Thank you very much. And then I have -2, 0. And it has to continue. And then I have 0, 2. And that's all I need. So this is a linear function with a hole in it. Can anyone give us the range, which is item 4?
All real numbers.
Ah,
Oh, it's got the 3 in it. Okay.
so
Negative infinity to -3. Is that -2? -1.
excellent. It's in the table, right?
Sorry, that was miserable.
The table tells us everything. Excellent. Well done. Good pick. Thank you. That was a good one. Any questions? Well done. Thank you so much. I'm sharing the screen again. Good. Let's move on. We know all this. We already looked at domains.
Could we do 75?
75. Simplify. In 75, we have 9 to 3/2. So here we changed 9 into 3 squared. We copy the base, multiply the exponents, and we get 3, and this is 27.
Thank you.
Thank you. I couldn't hear you.
Can't you also just plug that into your calculator?
You can.
Will we get in trouble if we do that?
No, absolutely not.
We just
No, but I'm too lazy. This is too easy to If I omit parentheses, if I have a TI-83 and I omit parentheses, who knows what I get?
Yeah, but I'm just wondering, like, if we did that on the written homework.
I am fine. Absolutely. Even on a test or yes, I'm fine. Yes.
Okay.
No problem there.